E9 square on lag of E9 square. E9 underscore square. Right. So, first, lag doesn't seem to be significant. F is not significant as well. However, this is just one simple way of doing it. However, in the model that we just ran a regression, where arc1 is significant and jet is 11.90. So you can try for more lag, L2 dot E9 skew. Again, it's coming out to be not significant. Anyway, I just wanted to give glimpse of Arch and Garch model, which you can try. There might be a little bit more, refinements we require in Arch and Garch model. And again, like I thought not to do it explicitly, so that as a variation of ARMA, you can work out to Arch and Garch, and you can do it. There are, of course, a lot of variation in Arch and Garch as well, like ARC-M, IGARC, EGARC, etc., etc. And most importantly, you use Arch and Garch model to model the variance of any return, right? Which you talk in terms of volatility and all that. So what now I am going to do today is to look at a little bit advanced stuff, which we can call vector autoregression, or you can call autoregressive distributed lag model, or vector error correction model. So let me start with the tests of stationarity, which I gave you brief yesterday about augmented Dickey Fuller and Phillips spin-off. So I just want to show you one table. Right. This is what I was showing you yesterday, and this is important to understand the non-stationarity and all that. I mean, though like the series is stationary or not stationary, just by looking at the pattern of the graph, you can observe that. Okay, so you see this three equations, right? So when you do the Dickey Fuller, then this summation term is not there. Summation term is actually capturing the lag difference, right? First difference of the second lag, third lag, fourth lag, and so on, right? So when you do the Dickey Fuller, then the summation sign is not there. Summation part is not there. However, when you do the augmented Dickey Fuller test, then this is there. So the point that I was explaining you yesterday is this is the most general equation that you start with drift term and trend term. So the equation that we were writing yesterday, which we were calling the raw test. So when you write yt is equal to yt minus 1 plus epsilon t. So this is the random walk model that you call. So, exchange rate today is equal to exchange rate yesterday plus some error, right? So, you can give the coefficient like a rho. So, what you want is if this rho is approximately equal to 1 or close to 1, then series is just the random walk. And this is approximately 1 implies yt is equal to yt minus 1 plus epsilon t, right? And that's why this is random walk, meaning non-stationary. So what we want is that when this series is non-stationary, then we model that in a vector autoregression model and integration model. OLS doesn't work. So whenever you're modeling, uh, whenever you're modeling and using, let's say, OLS can be used only if the series is stationary. However, most of the financial variables are non-stationary. So in today's world, uh, when the concept of vector autoregression and cointegration came, mostly vector autoregression and vector error correction model is being used. Right. So this is the row test that we were calling, and I wrote it alpha. So alpha is equal to 1 can be tested. So yt is equal to, or in other words, when you take the yt minus 1 both the sides, what you get is delta yt is equal to rho minus 1 yt minus 1 plus epsilon t, and this is, you can call it delta yt minus 1 plus epsilon t and delta yt. So delta is equal to 0 is the null hypothesis that you'll be testing, which is equivalent to say rho is equal to 1. And this is the rho test in simple, Dickey-Fuller framework. However, when you talk about the large number of lags when you are taking, then this is how you need to work out. Further, to tell you the story here, what you do is that there is a test of what we call, in the first case, in the first equation case, you check it out, gamma equal to 0 is the first test you do, and that is what we call tau test. So when gamma is equal to 0, is nothing but gamma is the coefficient of yt minus 1, right? Gamma is the coefficient of yt minus 1, which is precisely the same thing, saying delta equal to 0 that we just worked out. So, rejecting the gamma is equal to 0, right? Null is, you can say, so here, sorry, gamma is equal to 0, saying delta equal to 1, right? So alternative will be gamma not equal to 0. Rejecting the null, meaning no unit root, right? Rejecting the null, meaning no unit root, meaning stationary. So do not reject the null. Do not reject the null, meaning unit root exists, meaning non-stationary. So if this is non-stationary here, you go and test for simultaneously gamma is equal to alpha 2 equal to 0. This is alpha 2, which is trend, and this is gamma. You test this. Again, unit root you find. In this case, you go for testing the third one, which is alpha 0 equal to gamma equal to alpha 2 equal to 0. This is phi 2 test. Again, you found unit root, then go and test the second equation without trend. So you test for the gamma equal to 0, you found unit root, go and check this one. Again, you found unit root. Finally, you check the third equation without trend and without constant term, and gamma equal to 0, and this is what we call tau test. And if you found unit root in all the cases, then you declare the series to be non-stationary. However, as I was saying in the last class, anywhere you find that the series is stationary, suppose you found this to be stationary here, right? You stop here and declare the series to be stationary. You don't have to test the remaining tests here. Okay. So precisely in terms of tabulation, this is how you can present, right? So gamma equal to 0, tau tau test, gamma equal to alpha equal to 0, phi 3 test, and all this from equation 1, this 2 from equation 2, and this from equation 3. And if you find non-stationary in all of this, then you call yes, unit root exist. Okay. Similarly, you can do for Phillips-Perron as well. The way the critical values has been given here, right? The way the critical values has been given here in a similar fashion, I have written the critical value here as well, right? 1%, 5%, and 10%. Anyway, so these are basically the econometrics part of it. Now let's try looking at the importance of all these unit roots. So today we are not going to look at the different varieties of unit root tests, but you know what? When you talk about the unit root test, you shouldn't just be satisfied with Dickey-Fuller, right? Augmented Dickey-Fuller. You should also work out with Phillips-Perron. You should also work out with KPSS. So not only all those, six tests that you are doing from three equations, and you call it unit root exist, yes. Unit root exist, yes. Unit root exist, let's say no. So you can use the concept of majority and say unit root exists. You can call it yes, because in two of the cases, unit root exists. This is another way to kind of robustness check that you are doing in the unit root tests itself, right? Because, slight mistake that you do in time series might create trouble for you uh, uh, because time series is very sensitive in various ways. Also, this is important in terms of lag selection as well, which we were talking yesterday, and we'll be talking about that again today as well. Fine. So going forward, let's do the Dickey-Fuller test, and in Dickey-Fuller test, okay. Before we do the Dickey-Fuller test, what you can do is TS line, and plot the graph. X rate, CPI India, CPI US. Okay, and check that. So we plotted this yesterday as well. You can look at, all of them are simultaneously moving upward. After 2008-9, you find that consumer price index of India has moved really fast, right? Moved really fast. Moreover, like all of them are non-stationary, is clearly visible in the time series plot itself, right? Okay. Now let's look at the Dickey-Fuller test. D Fuller X rate, comma, trend, regress, lags, 2. So lag 2 that I'm giving randomly here. So you can check your own lag. So there is one way to kind of check the lag as well, which we discussed briefly yesterday. And the command for that is, let me just give the run to this, but VERSOC. This is vector auto regression that you can call it VAR, but when you are running a regression in terms of vector autoregression or ARDL model or co-integration, these are similar lines of models. So lag selection criteria, this Versok will help. So it will tell you the optimal lag by itself. So Versok, X rate, CPI India, CPI US. So if you write this command, yeah, so you can cross check here number of observation 597, and then this is telling star is optimal lag. Now we have 2 star. So lag 2 in case of HQIC and FPAIC if you're using, then lag 4. So precisely we are going to check for lag 2 and 4 both. However, let's start with 2. Let's start with 2. When 2 options are there, then you start with 2, and then if results are not coming perfectly fine, then we can go till lag 4. Okay. So this is the first unit root test. In a similar fashion, check with a drift term, and with a drift term, drift regress, lag 2, and third regression will be running without constant. So that's what we call no constant. No constant regress lags 2. Okay. Now, so these are one-tailed tests. So you check, this is the test statistics, minus 2.039, which is right to the 1% critical level, or 5% critical level, or in fact 10% critical level as well. Right? So this is non-stationary, random walk. We do not reject the null in the first case. With drift, same story, this is positive, and critical values are going to be to the left side of the distribution. So do not reject the null of random walk. Without constant, exactly the same story. So what you find is that exchange rate is non-stationary in level. Now, similarly, you repeat the test for consumer price index of India and consumer price index of US. So let me run for CPI India. CPI India.
Excuse me, sir, may I ask a question?
Yeah.
So actually, I'm using R software, and in that software, I'm just using a advanced DA for an ADF test, and I'm not proceeding like that as you have proceeded, testing for different, like taking drift and trend. Whether it is wrong or correct, I don't know. Please tell me, sir.
So one of the standard textbook in econometrics follows the way I'm doing, which is Walter Enders, which is widely recognized. And he has given a lot of justification for using the non-stationarity test this way. So this is the way I have been trained, and this is the way I have been doing, and I found it various other scholars have been doing the same thing. So I think this is the correct way of doing. I think you can model in a similar fashion even in the R programming as well.
Sir, there only ADF test is available, and when we put a series with ADF test, one test statistics used to come, and we define accordingly whether the series is stationary or not. But here I'm saying that you are checking for drift, then lag, and trend.
Yeah.
I think I should follow the same pattern in R also.
You can follow the same pattern in R as well. There must be something in R as well. Uh, Unit root test, I don't know when did I do in R programming, but I believe it must be there. Maybe like after the class, I'll also check, and maybe if you want, we can, like I can tell you later on whether it's doable in R. But I'm very sure it should be doable in R programming as well.
Okay, thank you so much, sir.
However, just to inform you more about the unit root test, as I was saying yesterday, these kind of tests are very easy in Shazam, and Shazam is one of the softwares we have been trained at the master's level. For the unit root test, definitely Shazam is good in terms of like start with trend and drift, without trend, then without trend, without drift. So you just give 3 lines of equations, and then they'll be testing all these 6 tests together, and they'll be providing you the result in a robust way. Anyway, so that's for additional information. Now, looking at the consumer price index of India. So if you look at the output, as you must be looking at in your output, so you can find that this is non-stationary even in this case as well. So you start with trend and drift. Trend and drift, what you find is that 1.76 is the test statistics. 1% is -3. Critical value is -3 at 1%, -3 at 5%, and -3 at 10%. So you do not reject the null of random walk with trend and drift. Just with drift, same story. You do not reject the null. Again, without trend, without drift, same story. You do not reject the null. And now in a similar fashion, you can cross-check for CPI US. CPI US, CPI US, and CPI US. What you will notice is that, CPI US is also non-stationary in level. So what we found is that all the series are non-stationary in level. Now, what normally happens, and often econometricians also make a mistake, is just because they are non-stationary in the level, they think that they are going to be stationary in the first difference. So they do not go and test for stationarity in the first difference. But there might be some cases where some of the variables are not stationary even in the first difference. So it's nice to check the first difference as well. So now you repeat the test of exchange rate, consumer price index of India, CPI of US for the first difference as well. Now, when you test the unit root for the first difference here, you will find that they are stationary. All of them are stationary in the first difference, the kind of data that we have taken. So I'm not testing that. You can do that because again, it's a repetition of the same thing. So you can do that. Do the stationarity test of the first difference of the variable. Okay. Now the next task, if they are non-stationary, so what we will start with is, let's start with ARDL approach, right? Yeah. So let's start with ARDL approach, or let me just again give you the brief about a little bit of difference between, or the idea about co-integration and ARDL and all that, right? So we have exchange rate, we have CPI India, and then CPI US. Now, what we find is that they are non-stationary in level. Non-stationary in levels, but they are I1. They are I1. So what it means is that these exchange rate, when they are non-stationary and you are just running a regression of exchange rate beta 0 plus beta 1 CPI India plus beta 2 CPI US. When they are non-stationary in level, what you might find is that the relationship between consumer price index and exchange rate can be spurious. Consumer price index of US and exchange rate can be spurious. And when we say spurious, it means is that non-stationary series, one unstable variable cannot really properly explain another unstable variable, right? It's saying something same as, uh, one madman cannot be a good support system for another madman. So this is something like spurious that we talk about. So in terms of intuition in economics, when we talk about spurious, uh, we are saying that consumer price index might have been explaining exchange rate in terms of varying it, but when they are non-stationary, how much percentage change in the consumer price index should actually be explaining how much percentage change in exchange rate will not be truly reflect in the non-stationary series. In that sense, this can be spurious. So when they are non-stationary, it's not a nice idea to work with the OLS. And since you are not going to work in the OLS framework, if they are non-stationary, the next best that you should start working is the vector auto regression. And when you talk about vector auto regression, what it means is that you get three variables here: uh, uh, exchange rate, CPI India, CPI US. And if you're selecting lag 2, as we have just tested, exchange rate is the function of exchange rate T minus 1 and exchange rate T minus 2. And similarly, you'll be entering for CPI T minus 1 and CPI T minus 2. This is for India, right? India. Similarly, CPI US T minus 1, CPI US T minus 1. Similarly, you will be getting another equation for consumer price index of India, and all these 6 lag variables will be coming here in the second equation as well. Similarly, in the third equation as well. So what you get, this is structure of the equation, structural VAR. So there is something called SUR you might have studied in econometrics, advanced econometrics, seemingly unrelated regression. In that case, what do we assume? Error terms of one equation are not related with the error terms of the second equation. However, that is one of the things that we break here. So error term of the second equation will be affecting the equation of exchange rate, or maybe equation of the consumer price index of US. Okay. Okay. So one more thing, since equation is non-stationary, so there are different softwares deals the equation in a different way. So when you deal in this data, since this is non-stationary in the level, you have to take the first difference, D dot exchange rate. D dot exchange rate lag 1, D dot exchange rate lag 2, and likewise for others as well. So first difference, you have to give the command. Similarly, for others as well. And you get the result. You can cross-check the significance of each variables. and checking the significance of each variables. Then you can look at the shock. Shock is in like in the first equation you will be finding epsilon t1. In the second equation, error term, you will be finding epsilon t2. You will be finding error term epsilon t3 in third equation. So what happens is that, suppose consumer price index of India, I mean, inflation is really, really high, right? Because of various things, oil prices or whatever. And we want to check the effect of shock in the consumer price of index of India on exchange rate here or not, right? So what you will find is that consumer price index lag 1 has been considered here. Okay, so uh, shock is coming in the consumer price index of India, but this is entering into the equation for exchange rate as well, and then that's how this is affecting the exchange rate. So this shock is affecting not only the consumer price of index of India, but then also going to affect the exchange rate of India as well. So how much time exchange rate is going to take to get stabilized after shock affects the structural equation. So somebody has a question. Just a moment. I get back. Nihar, what is the command for different tests under ADF? Just a clarificatory question. We use only stationary series. No. So all these three variables are stationary in its first difference. So introduce the equation, introduce the variable while giving command in terms of first difference, because they are stationary in the first difference. So you need to introduce the variable like a stationary variable in the equation. So that's the way like we introduce b dot exchange rate, and in the right hand side d dot lag of all the three variables. To answer, so you guys want do file. पहले ही डू फाइल दे दूंगा तो कैसे सीखोगे? कुछ कमांड तो साथ में दो ना. Let me just give you. Yeah, check the do file in WhatsApp group. What I said was, since variables are stationary in the first difference, so when you are entering the equation, see, I mean, there is a way to give the command in Stata. So the result, the way it will be coming is with the first difference. Okay, the way result will be coming with the first difference of the variables. And different software packages have different way to deal. Sometimes you need to introduce the variables in the command window with the first difference itself, not the level variable. Okay, but output is going to come with the first difference only, and that's the interpretation that you have to give for that equation. Some of these things we are going to, discuss while we do the programming. Just wait for a while. Okay. Share the screen. So now I have shared you the do file. What you can do is you can simultaneously do the programming with me, and you can save a little bit of time uh, um, by not writing every command in the command window. But you can simply copy and paste those commands from do file to the command window.
Am I
Because
audible?
yes,
Yeah, Ganesh, can you please repeat the last part that you were explaining the error term of one equation is connected with another equation? That is, I think
okay,
you were
that
explaining about the
explanation you
structural
wanted.
error.
Yeah. That is really important. Okay. So when you write the equation exchange rate as the function of exchange rate T minus 1 and exchange rate T minus 2 and CPI similarly for the T minus 1 and T minus 2 and CPI US T minus 1, T minus 2. So what you get is you get epsilon T1, I mean error term for this equation. And similarly, CPI India, you get epsilon T2 and CPI US function of, so here you get epsilon T minus 2. So when we say, oil price suddenly gone up, meaning that's like a shock to the consumer price index for India. So shock is normally captured or come through the, or that is being captured in the error term, right? And this is going to affect the consumer price index. And this consumer price index is also entering as a right hand variable for the equation of the exchange rate. So this shock, which has been gone into error term, is also going to affect the exchange rate through this variable, which is entering here. Can you see the equation that I'm writing?
Yes, it is visible.
So shock is coming in this epsilon T minus 2, affecting the consumer price index. And since consumer price index enters as the right-hand variable in the equation for the exchange rate as well, so this is also going to affect the exchange rate as well. Is it clear?
Yeah, this is clear. Just one question. This CPI India is also into the equation of CPI US or not?
Exactly. So you know what? When
Hmm.
shock comes in the uh, second equation, we try to look at the response of the exchange rate to this shock and response of the consumer price index of US as well to this shock. We
Okay.
get we get in both the equations. So in this structural bar, what we get is that when one shock comes in any of the equation, it's going to affect the remaining equations as well. That's what.
Okay, wonderful.
Yeah.
Okay.
Okay.
Thank you
Now,
so much.
no issues. Moving forward, let's run the, yeah. So other thing, one more thing, together with this. Now I talked about, you know, exchange rate, consumer price index of India, consumer price index of US are non-stationary in level, but they are stationary in the first difference. It means if we run a regression, exchange rate on CPI India plus beta 2 CPI US, and you get residual term, right? So what we say is that some linear combination of these variables are going to be stationary, we say. Okay. We say some linear combination of these variables are going to be stationary. It means you can write alpha 1 exchange rate plus alpha 2 CPI US plus alpha 3, sorry, CPI India, CPI US, right, is equal to error term, right? So some linear combination of exchange rate, consumer price index of India, consumer price index of US are going to be stationary, we are saying. And when we are saying this linear combination is going to be stationary, it means we are going to check the stationarity of the residual. And once we could declare that error term is stationary, then we confirm that they are cointegrated in order 1. Cointegrated in order 1. Now, when you are modeling the ARDL model, you have to specify certain variable as dependent and certain variables are as independent variables. However, when you cointegrating the variables, right, when you're cointegrating the variables, then there is nothing called one as dependent and others as independent. Any one of them can be dependent or independent, depending on what you are interested in to capture the equation and explain your results. Okay, so this is one of the difference. Though you can capture the error correction term in both the cases, in both the cases. Anyway, so in ARDL model, when do you model the ARDL? So when we get all our variables to be non-stationary in the level, but stationary in the first difference, it's good to go with the cointegration. It's good to go with the cointegration, right? And there are 3 methods normally in the cointegration. However, if some of the variables are stationary, some of the variables are non-stationary, then it's good to go with the ARDL model. It's good to go with the ARDL model. You can take different lags as well in the case of ARDL. And you can specify one as the dependent and others as the independent variable. So that's how you can work out and differentiate between ARDL and cointegration. So for the cointegration, we use non-stationary. For the cointegration, we use non-stationary.
So if
Again,
this is
even in the sorry.
so if series are non-stationary at level, so and stationary at first difference, so we can use series at level for checking co-integration and as well as for ARDL.
Yes, yes.
Okay.
Yeah. And Stata has a smart way of doing it. Will be telling you, what is the lag you're going to use and how, like how many co-integrating relationship exist and all that. We are going to do some of those things. I hope these concepts are clear to you guys, right? So when should you go with ARDL? When should you go with co-integration? Okay, now let's start with ARDL. Let's start with ARDL, and you must be able to look at uh, the do file. Though, like in our case, all the variables are non-stationary in level and stationary in the first difference. But let's try to do ARDL with this. Though co-integration is going to be more appropriate in our case. Just in case, if you happen to estimate the ARDL model in your case, you can model giving these commands, right? So You can just copy and paste that command, which you can familiarize in greater detail later on. So I'm just going to give the ARDL command. Okay, so this command, that maxcoms that command that you're giving in the right hand side, AIC maxcomp. So you are allowing Stata to decide for you what are the lag. Stata is going to tell you that what are the lags that you should consider while estimating the ARDL equation. So ARDL telling you is that there should be 6 lag for exchange rate, 3 lag for CPI India, 2 lag for consumer price index of US. Okay, and that's the way like you can get the results as well. Now, this is just the ARDL model that you ran, where different lags is being selected by the Stata itself. F statistics is highly significant, though what we are more interested in is to look at how the error term is going to behave, whether error term is stationary or not. Okay, so what you can do is you can look at the next command, which is estat btest. Oh yeah, so one of the command that we needed to give, we need to give EC1 and lags 6, 3, 2. So this EC1 is the error correction term that we are capturing here. The result is precisely the same as the earlier. What you get here is, this is long run relationship. And this is one of the difference again with the co-integration, is that in the case of ARDL, you get both kind of results, long run and short run. However, in the co-integration, you get long run relationship only. So they are non-stationary in level, but they're stationary in the first difference. So what we say is that linear combination of all these 3 variables are going to be stationary in the long run. That's what it means in the case of co-integration. So now including the error correction term. So like this error correction ADZ is adjustment term, and this is important. And this has to be negative. This has to be negative. What it means is that 1.3% of the deviation of the exchange rate is going to be corrected within one period, right? Within one period. This has to be negative. Negative basically tells you about the stability condition. It means it's going to pull down the deviation towards the stable equilibrium. Other coefficients you can check whether they are significant or not significant. Particularly, consumer price index of US is significant, which is 3.11 T statistics. Basic interpretation in terms of like this 0.57, 0.12 you can explain. However, CPI India is not significant. Error correction term is or error term is significant, where T statistics is minus 2.47.
Just one question, Ganesh here.
Yeah.
In the result part, in the long run case, What is the interpretation of the coefficient of CPI India? Does it give elasticity?
No, it just gives the percentage change because we have not captured the variables in log. If it
Okay.
would have been captured in log, then it would have given the elasticity.
So the interpretation here is that 1% or 1 unit change in CPI India will increase exchange rate by
Yeah,
0.12%, something like that.
12%. 12%.
12%.
Yeah,
Okay, yeah, this is not in log form. Okay,
yeah,
okay.
this is not in log. Yeah,
Yeah, thank you.
yeah. Um, uh, Other results are quite interesting. You can find like T statistics are significant in all the lags in the case of exchange rate. Meaning, you see, lag 5 till lag 5 is explaining the current exchange rate perfectly fine. And since this is monthly data, so last 5 months exchange rate data is explaining the current exchange rate. Uh, in broad terms, you can analyze, and all of them are significant. Consumer price index, first difference is not really important, but lag difference, first lag difference, not significant. Second lag difference is though is going to be important. Um, hmm. uh, Again, consumer price index is available monthly or weekly. It's monthly, I guess, right? So, if I remember correctly, consumer price index data is available monthly. So there are some lag effect you can notice because exchange rate you find every day, and of course, like monthly data when you get the exchange rate, that's average of the entire month. Um, so exchange rate explaining itself can have a different story, which we are able to capture here. Whereas consumer price index affecting the exchange rate will be having a little different to look at. However, what we notice is that um, second uh, 2 period lag is explaining the exchange rate. Whereas the consumer price index of India, first difference is explaining, and then first lag is explaining really well. Other interpretation you can look at. In terms of stability, it's quite stable at minus 0.01. Now, fine. Uh, uh, in addition, you can look at the other tests of
Ganesh, just one more question.
sure.
Yeah, so in these answers, there can be a case like our error correction term is significant, but in the long run, the coefficients are not significant.
Error correction terms are significant.
Significant, but the long
Error
run,
correction term are significant, but it
but
might not be significant in the long run.
yeah,
Um, in the case of ARDL, when we get the result of the error correction terms, which is negative and significant, the only interpretation of that uh, is, this is going to pull down the deviation towards the equilibrium. That's what we say. If it's not significant, it means your equation is not really valid in terms of capturing the model really well, like a stable equation.
so this means that apart from F test that we check, we also need to check uh, the basically error correction term and also the coefficients of long run
Yeah,
results. Basically, if error correction term and the long run results both are significant, then we can say that our model is uh,
good.
good. Okay,
Yeah, yeah, yeah.
thank you.
So, yeah, so the error correction term must be negative and significant to say that your equation is stable. Because, that is one of the things we are looking at. Because when the equation are, variables are non-stationary in level, they have to be stationary, or the linear combination of those variables should be stationary in the long run. And that we can capture through error correction term and the residual term. And for the residual term, we can again cross check now, which you can give the command reg store, EC reg, estimates, restore, EC reg. We are storing it. Now EC reg is active, so we can check the EC reg. Is regress, then is Durbin Watson, D Watson. Durbin Watson is basically tells you about the serial correlation of the first order, and you can find that Durbin Watson value is close to 2, right? So there is no serial correlation, and when Durbin Watson value is at 2, it means D is approximately a 1 minus rho that we say. So if D is close to 2, it means 2 1 minus rho captures the serial correlation, 2 cancels out. So rho is equal to 1. No, 1 minus rho. I'm forgetting the equation for this. I think this is how it should be. D is equal to, if Durbin Watson value is coming out to be equal to 2. But anyway, in our case, it's 1.98. So rho is telling
Yeah, I
you
think
really,
this
really
is the
high.
equation. Yeah.
This is the equation, right?
Yes, this is how we write it. Yeah.
So this is how we write it. But it's coming out to be 2. It means rho has to be less. Rho should be less, right? One minus rho. Anyway, so I mean, this calculations that you can do. I think something I'm missing right now. But what simply I'm trying to say is that the general interpretation says is that when your Durbin Watson value is close enough to 2, then there is no serial correlation. Alternatively, you can check for Breusch-Godfrey, which is E stat, BG Breusch-Godfrey lags 1. So the first order serial correlation we are checking with the Breusch-Godfrey test, LM test, right? And then you find the test statistics value 1.76, p value is 0.18. So very high p value. Null hypothesis is no serial correlation. So you do not reject the null of no serial correlation. Okay. So we confirmed from Breusch-Godfrey that there is no serial correlation. And E stat, IM test, white. White test is basically for the heteroscedasticity, right? And null hypothesis is homoscedasticity. Chi-square is really, really high. So you reject the null of homoscedasticity. And yes, there is heteroscedasticity, it's telling. And, like you can look at this key. So there is heteroscedasticity fine. So you can iterate to different other lag selection as well. But, Stata already told you about 632. So finally, I mean, this is the kind of ARDL model that you can be satisfied with. Or some variation of this you can try. Maybe you can take the log of the equation just to get the results. Maybe slightly different, and robustness can also be checked simultaneously when you take the log of those variables. So ARDL, X rate, CPI India, CPI US lags. Then if you just write EC This is the equation which we have already seen, and we are interested in this adjustment term and significance of the lag variables in the short run and long run, and that's all. This is the equation. So like you can also look at the impulse response function, etc., and then shock affecting um, the exchange rate and so forth. But that is more important in the case of co-integration, because co-integration and VAR, because here we consider precisely only one equation which we are interested in, and we declare one to be dependent and others to be independent, right? So you can simply give a shock to the consumer price index of US or India, and then you can simply capture in the exchange rate. However, other way around, you should not do is expected in the case of ARDL model. You can read a little bit more and look at some more tutorials in the internet for the ARDL. But for basic understanding, this is what I wanted to give in the class. Now, let's go for the co-integration. And first, I have worked with the Engel-Granger test. Co-integration. And in the Engel-Granger test, you simply run a OLS of the equation and you test on the residuals, right? That's all. And even in the case of Engel-Granger, you worry about the causality. Worry about the causality meaning you basically declare one variable to be dependent and others can be independent variables and so on. So looking at the command here.
So, sir, in ARDL model, we do not need to think about causality. Is it okay if we are trying to regress and causality relation is not there?
In the ARDL model, since you work out with one equation where one is dependent and others are independent, where in our case we were interested to look at the effect of the consumer price of index of India and US on exchange rate. So precisely we are saying is that consumer price index of India and US is affecting the exchange rate. However, in terms of testing the Granger causality test, if you are interested, you can do whether it's really affecting the dependent variable or not. I think I haven't seen, but I think it's doable. I haven't done though. I think in this question, I'll get back to you later on. I mean, I'll be commenting you back in your WhatsApp group. So let me just write this question.
Okay, thank you, sir. Thank you, sir.
However, in the case of Engel-Granger co-integration, there is another important part you work out is basically you test for the Granger causality as well. Anyway, one of you have requested about the Granger causality yesterday, and then specifically I have not really done the Granger causality test, though if I remember the command, I'll do. Otherwise, I'll tell you later on. Anyway, so regress exchange rate on consumer price index of India and US, and with no constant, what you find is highly significant CPI India, CPI US. Now, what we do in the Engel-Granger is we capture the residual predict residual res. You can cross-check the Excel, the spreadsheet as well. So this is where the residual is being captured. Then predict so it's the same thing. Double receipt. Yeah, so what we are interested here is basically to regress the first difference of the exchange rate on the lag of the residual, right? So run it and check the results. Right? What we did is regress first difference of the exchange rate on the first lag of the residual and first lag of the residual and first lag difference of the exchange rate, first lag difference of the CPI India, first lag difference of the consumer price index of US. So what you find is that minus 0.011. So if you look at the error correction term of the ARDL model, which is quite close with the coefficient here for the first lag of the residual here, right? And this is significant, and this is significant. In terms of command, this is how much it is in Engel-Granger. For the broader generalization and interpretation, you can read Engel-Granger basic econometrics book. It's been given in Gujarati itself, but then I do not really recommend Gujarati. You should read some advanced book. Engel-Granger himself, they themselves have written a book on econometrics, advanced econometrics. Some of those books you should read. Other thing to graphically, visually, if you want to observe, you can plot the residual and check.
Ganesh, I have a clarificatory question regarding
Yeah,
this
yeah.
Granger causality.
Mhm.
So do we use two variables at a time in Granger causality? Because we would like to look at whether there is a bicausal relationship or there is a
Mhm.
unicausal relationship. So do we
Mhm.
look at two variables at a time, or we can have more than two also? Like you have
So this
considered.
is not the Granger causality test we are doing. This is Engel-Granger cointegration test.
Acha, acha, sorry.
Ha, ha. Yeah. So, but in terms of Granger causality, that's what you are saying is correct. Okay.
Okay.
I'll tell you about the Granger causality separately in the WhatsApp because I think that we won't be able to do because I have not even put it like a practice part for the workshop.
Okay.
Yeah. Okay. So you can look at the residual of running a regression. What you find is that the so this is how it is. Expectation seems to be 0. Average residual seems to be 0. And stationaries, like there is mean reverting tendency of the residual you can notice. Other plotting that I tried doing is to look at residual and lag of the residual. So you can do that, Nihar. But that shouldn't be a big problem. Or we can try doing that. We can experiment that. That's not an issue. Okay. Residuals and lag of residuals. So Nihar is telling that var Granger is the command. So you can write help var Granger, right? Granger causality. So it will take you to the PDF. This is the way to kind of find out. This is also a kind of learning in the workshop. So whenever you do not understand anything, you simply write help Granger, right? Causality. Yeah. So it will take you to var Granger. You click on var Granger, and then it will be telling you view complete PDF manual. So we clicked here, and then it will take you to the PDF. And in PDF, this is the command var Granger. Perform a Granger causality test on vector autoregression. This stata command, but stata command it's been given first, and then they'll be giving you an example of some case, and then you'll be testing. For example, this is the regression they are running, and var Granger is the command they are giving. So pairwise, they'll be getting the relationship the way one of you were saying. So for example, if you simply run a regression here, var Granger.
So first you will
that
have
should be
to
with
create
var.
a var.
So,
Yeah.
yeah, that should be with var, right? That should be with var. Just a moment. It should be var. And var Granger. Yeah. So you get this result, and equation exchange rate excluded CPI India, CPI US. So exchange rate is the function of CPI US. CPI India is excluded for the first equation. So you find the chi-square to be 12.06, degree of freedom 2, because two variable at a time you are working out, and then p-value is this. So you need to look at what is the null hypothesis. In this case, null hypothesis normally is to be no Granger, if I remember correctly.
Yes, sir.
Yeah, right. So null hypothesis is no Granger. So rejecting the null, meaning there is Granger causality, meaning consumer price index of US is affecting the exchange rate. Similarly, in the second case, CPI US is excluded, and then you are looking at the effect of CPI India on exchange rate, and then you find that yes, there is an effect. Similarly, in several other cases. However, in the case of CPI India and exchange rate, where what you are doing is CPI India exclude exchange rate. So what you are doing is you're simply looking at the effect of consumer price index of US on consumer price index of India, and this is not Granger causing, meaning you do not reject the null of no Granger cause. Okay, except this, yes, causality is kind of working fine, and effectively, the way like we are interested in the equation is also, the effect of consumer price indices on the exchange rate. So exchange rate precisely we are considering to be the dependent variable. So that's fine. So that's fine. Even in the case of Granger causality, it's clear. So this is how basically, like you work out in Stata. So whenever you kind of stuck somewhere in the programming, that is how machine works. Sometimes you are giving perfectly good commands as well. Sometimes it doesn't work. Particularly that kind of thing happens more in R programming, I have found.
Excuse me,
Less
sir.
in, yes.
So can you please repeat the interpretation part of Granger causality?
Yeah, so I said here, see, equation is given, equation of the exchange rate. And second column you can look at is excluded, meaning consumer price index India is excluded. If this is excluded, what is left? What is left is consumer price index of US. So what simply we are looking at is the effect of consumer price index of US on exchange rate. Okay. So null hypothesis is no Granger cause and test statistics value is 12. So you reject the null of no Granger cause, right? It means there is a Granger cause, meaning consumer price index of US is affecting the exchange rate. Second, you exclude consumer price index of US, right? And then you simply look at the effect of consumer price index of India on exchange rate. And yes, consumer price index of India also affect the exchange rate. And excluded all, meaning you exclude consumer price index of India and consumer price index of US as well. What I noticed here is that exchange rate lag must be explaining the exchange rate lag must be explaining the exchange rate. So let me just cross check quickly, like whether R Granger. Yeah, these are additional tests of the War Granger. The null hypothesis that D of log inc does not Granger cause D log inc inf cannot be rejected. Similarly, we cannot reject the null hypothesis that the coefficient of the two lags of B in the equation for are jointly 0. So we cannot reject the hypothesis that does not Granger cause. The third test is with the respect to the null hypothesis, the coefficient of the two lags of all the other endogenous variables are jointly 0. Oh, just a moment. Something wrong I have done. DLN inc does not Granger cause DLN in cannot be rejected. Okay, so I don't know why this excluded term is coming here, but from the interpretation given, what it says is that exchange rate does not Granger cause CPI India. Exchange rate does not Granger cause CPI US is the null hypothesis. Exchange rate does not Granger cause CPI India, CPI US and first lag of CPI India and CPI US, and that's why the 4 degree of freedom is coming here. And we reject the null in all these 4 cases. So this is the interpretation. Okay, CPI India does not Granger cause the exchange rate. We do not reject the null. CPI India does not Granger cause CPI US, and so on. Okay, so just read from the PDF once just to confirm, but this is what I got about the consumer price, about the Granger causality. Okay, now let's go for other tests of cointegration. There are 3 main methods of testing for cointegration. One we have briefly done is Engelgranger. There is Johansson, which is the most famous one, and Phillips Ollier, right? So Johansson is the most used. So anyway, let's give this command first and select the rank. Just a moment. Right? This is basically to select the lag, which we have already done, 2 or 4. Then we go and next rank according to the rank of the variables. So we give the level variables in the command, and then we are deciding on the rank. And depending on the rank, we will be selecting the number of cointegrating relationship. Okay. So there are 2 methods. One is eigenvalue method. Another one is the trace statistics method, right? Trace statistics method suggesting this start. So selected rank is 1, right? Selected rank is 1. So only one relationship exists, or only one cointegrating relationship exists among all these 3 variables. Okay. So with 2 lags, let's check. Then we'll check with 4 lags. It's going to give you the same, right? We have already selected the Versok gives you the lag, right? So we selected this 2 lag, and then we will try for the 4th lag, and then we'll check the cointegrating relationship. So with the 2 lags, it's giving 1, and I believe even with the 4 lags, it's going to give you the 1 cointegrating relationship only. Okay, so yeah, it's a good thing about Stata is that Stata tells you which maximum rank that you should go with, right? So number 1. Okay. Now let's run the vector error correction model, cointegrating vector error correction model. So yeah. So Johansson and Juselius cointegration method. So the way you run a regression in case of vector autoregression, in a similar fashion, you get the result here as well. So you find D of the exchange rate. And this is the error correction term you find, right, which is minus 0.001. Unfortunately, this is not significant here. So this is significant. In the case of CPI India, negative and significant. In case of CPI US, it is significant. In case of exchange rate, it is not significant. Okay. you can cross-check different lags. So in the case of co-integration, what you will find is that first lag difference has been considered in all the cases, right? First lag differences. And this is the co-integrating equation. So when we write the co-integrating equation, like we said, alpha 1 X rate plus alpha 2 CPI India plus alpha 3 CPI US. Linear combination of all these series is going to be stationary, where we check the stationarity of the epsilon. So when we get the equation where coefficient is 1 for the exchange rate, what we precisely mean is that X rate plus alpha 2 by alpha 1 CPI India plus alpha 3 by alpha 1 CPI US 1 upon alpha 1 epsilon t. You can take all of these variables to the right hand side to express equation exchange rate as a function of CPI India and CPI US if you are interested to estimate the equation for the exchange rate. So this is just the way of writing the equation, and we are interested in checking the stability for the error term. Okay. Lags to rank 1. Exchange rate, CPI India, CPI US, lags to rank 1 is yeah. So if you do not want that big table the way like we got earlier, then we can include this command, no e table, right? So that big table will not be coming, and this equation is, it will be giving at rank 1. And since one co-integrating relationship we got, so beta is exactly identified. And the coefficient, which is alpha 2, you can write the equation like this. This is the coefficient of CPI India. It is going to be, which you can express like, delta 1, delta 2, CPI US, right? X rate. And equal to, you can put it in here depending on what is the sign of delta 1 and delta 2. So if this is negative here this side, if you take the right hand side, this is going to be positive, and so on. So there is a way to test constraint defined. So some of these things, I have kind of seen in the literature and put it in here. However, in terms of interpretation, you need to cross-check in the internet, like how and what are all these means.